As hosters, there are different ways you can deploy infrastructure, right? So you can continue with the types of servers and the form factors, et cetera, that you've used previously successfully, and you can deliver additional resources, you can grow your environment, you can support additional customers. However, there's another way to get there in terms of using specialized hardware and specialized solutions, and that's what the concept is of today's discussion. What I'm going to do is go through different parts of your infrastructure. So we're going to talk about your overall environment, we're going to talk about your servers, we're going to talk about different workloads, etc. And here's the concept. By specifically choosing technologies that you may not or may not be aware of, you can deliver more margin to your bottom line. It's that simple. If it costs you less to acquire the equipment, if it costs you less to run the equipment, that means you can grow your environment and charge your customers less. You can grow your environment and deliver more money to your bottom line. You can grow faster, more flexibly. So that's what we're going to talk about. By the way, I'm happy to answer questions during the session itself, or we'll have time for questions at the end. So let's take a look at the market. Starting at the top. Estimates are that by 2014, 3 billion people will connect using the internet or using mobile technology. So just to give you a couple of data points there, right now the total population of the Earth is 6.9 billion people. So even allowing for growth, that's close to half of the world's population connecting over the internet or connecting through mobile technology. So that's a very big customer pool. Half is good opportunity for you and for us. The second part is it's also good that it's only half. So this is a market that's going to continue to expand. And by the way, I will give us one prop. As you saw the banners outside, right now, our estimate is that 1 billion people are connecting on Dell technology. So we're actually quite pleased with our status in the market. Let's take a look at what that relates to in terms of spending. So in 2012, the estimate is that $42 billion will be spent on cloud services. And if you look at emerging markets where most of the growth is coming from the cloud environment, $440 billion is expected in 2011, which is a 10% growth. And this is an area where you're seeing growth, whereas in lots of parts of the industry, it's flat or minimal growth. So there's lots of business to be had. And then finally, what does that mean in terms of content? So the estimate from IDC is that the digital universe, the amount of data out there, will double every 18 months. If you extrapolate that out, that means in 2020, there will be 35 zettabytes of data in the digital universe. And depending on whose estimate you believe, in 2009, the entire digital universe was something north of 500 exabytes. So that is a huge growth path, and that means that hopefully we're all in the right business. If you take a look at what that means in terms of server deployment, if you look at the chart at the top in the green, that is the typical deployment model for IT today, right? So typical traditional deployment model where you're using a dedicated server for different applications. This is inside a company's own data center. Or virtualized environment, same thing. Still an internal type data center running traditional applications. Much less so on the public and private cloud side, but as you look forward over time, look at the blue curve, that changes just like you would expect. So in the next 3 or 4 years, the majority actually moves over to public and private cloud, like we've been talking about, like you've been hearing for years. And if you look at the chart at the bottom, this is the magnitude. So in 2010, 70% of the servers of the infrastructure were in internal data centers, 30% being external. By 2014, that changes to 50-50. So again, reduction in IT spend in in-house data centers, lots of growth in external data centers and web data centers. So this is just a snapshot of the market. This is what we see coming, and this is why we think it's important to consider how to best profitably grow. So like I said, we're going to talk about a few different things. We're going to talk about infrastructure readiness, looking at your entire infrastructure. We're going to talk about optimal workloads, how you would size workloads to the hardware. We're going to talk about complex versus simple solutions, and we're going to talk about how to deal with volatility of demand. As you grow, you have to deal with spiky demand. So, infrastructure readiness. This one's pretty simple, and we'll talk about it more in the slides coming up. On the left-hand side, you see a typical rack of servers. So if you're a hoster and providing dedicated servers to customers, maybe you're running typical pizza boxes, 1P1U, 2P1U, etc. Typical 42U rack. This particular one's driving about 4 kilowatts of power. Okay? That's your dedicated server solution, and that has worked just fine. And you can continue to grow that way, and you'll reach the goal line in terms of growth and supporting more customers, etc. The point I'd like to make, though, is that there are new technologies out there. And on the right-hand side, we're going to talk about the concept of microservers. And a microserver is a pretty simple concept. It's more dense. It spreads the cooling and power costs across an entire chassis, and it means you can deliver more, in this case, dedicated servers per rack. It also means the cost to operate those is going to be less. And we're going to talk specifically about how some customers have used those and driven higher margins and driven a competitive advantage. You can do the same thing on the, if it was 51 unit, you can do the same thing if it was 4P, etc. The concept is, let's talk about some new technologies, some new architectures that are a little different. Now let's talk about your data center. So not everybody owns their own data center. For the folks that do, there are a couple of different things to consider here, right? Because again, anytime you spend money on something other than your IT platforms, you're spending money that takes dollars away from your bottom line. So on the left-hand side, typical data center. In a typical data center, and I've been in a lot of data centers, you walk through the data center, the racks are not full because the data center can't handle the thermal load. There's a mixed environment, so there are really high-intensity IT mixed with low-intensity IT, so it means that you have mixed cooling requirements. Maybe there are hot and cold aisles, but there isn't hot aisle containment, things like that. So the first point is, take a look at your data center. It's really easy to get us or somebody else to take a look at your data center and help you understand what's going on. Gee, why are these racks hot? How come I'm having to run these coolers full speed and this guy is basically shutting down? So understanding your data center environment will really help you in reducing operational cost. The concept you're aiming for is PUE, right? So PUE is simply a metric that helps you quantify how much additional power a data center requires on top of the IT load. Pretty simple. Let's say you have a data center running that your IT load pulls 100 kilowatts. And if you have to pump 160 kilowatts of power into that data center, that means that your PUE is 1.6, which actually would be fairly okay, better than average. If you go through your data center, if you do high-intensity IT, low-intensity IT, if you do aisle containment, things like that, you can bring down that additional requirement of power, which means you can bring down your operating costs. And it is not difficult to do, believe me. So simply going through and understanding your data center environment can reduce your operating costs. As you build up new data centers, my advice would be most of the cost in building out data center space comes from the infrastructure equipment itself, not from the building, not from the shell. So what a lot of people do is as they build out new data center space, they do it in rooms, and they only populate rooms with cooling equipment and power equipment, et cetera, as they start growing into their rooms. So there's a way to build a brick and mortar data center efficiently so you don't pay a lot of money up front. There's also the concept of a modular data center. And this is, as you probably heard, a data center in a box. This is a container-based data center. We have one, other folks have one. The concept is pretty simple in that it lets you control the environment completely. And when you control the environment completely, meaning you control the airflow, you right-size the infrastructure to the IT load, et cetera, you can be really, really fast and really, really efficient. So in this case, for example, we actually delivered a modular data center with a PUE at 1.03. That means there's 3% additional load for cooling and for power transformation, et cetera, on top of the IT load, which is just crazy efficient. And it means, again, that's less OPEX for you and less spending required, more margin. I said that we would talk about specific customers, and so you would understand that I'm just not up here talking, but folks have delivered and received real value out of this. This is a fairly large example. This is Bing Maps. And Bing Maps came to us and said, hey, we need a solution very quickly to be able to deploy a lot of IT closer to our customers. So in this particular case, Bing Maps was looking at 440 servers, 178 petabytes of data, and they were trying to get an environment that's as efficient as possible, and they needed it really fast. So what they received is 8x reduction in cost to power it. What they received is 5x the capacity that they originally had. And just to give you an idea of how this stuff works, I'm going to show a brief video to help you guys understand just how fast something like this can be deployed. So this is one of Bing Maps locations actually being created. So pay attention, please, to the dates at the bottom. January 28th, their first digging a hole. So on the 19th of January, it was dirt. This is the modular data center arriving. As they take the covers off and take the wood out, you see that it's already deployed with brine. So you can choose to do that or not. It's a really fast way of deploying down to unit and it's integrated. That's the evaporative cooling. That gives us all the efficiency. It lets us cool without external cooling sources, so you use outside air. This is a module that lets us mix air between the heat generated by the servers and external air, so it means you can operate in a broader range of temperatures. And if you see, it actually took longer to finish that building, which is the storage building, than to deploy the data center. So, January 20th to April 21st, the lights were actually on, that data center was operating, and started out as dirt. So, obviously that's a large example of how to deploy additional infrastructure, but it's really efficient and really fast when you need additional data center space. So, that's the external infrastructure. Now let's spend a little bit of time talking about workloads. We talked in the beginning about deploying a typical server, right? 2P1U, 1P1U, the servers we're all used to and we all kind of grew up with, if you will. My point to you on this is simply on the left-hand side, dedicated hosting, for example. A lot of your customers probably, as you know, a lot of your customers probably don't need that much performance. It's a small customer, they don't need a lot of capacity. What you're seeking for them is the lowest possible cost solution for them, still in a dedicated server. So for that type of environment, we have something called Microservers. That's a new category to the industry, which we'll talk about more in a minute. As you move up in the scale, and presumably you have a growth pan that would get customers up to more capacity as they grow, you can offer them solutions also. There's kind of a 2D version of that. Again, the concept is shared infrastructure, sharing the cost of operation across multiple nodes instead of a single server, each with its own power supply, each with its own fans, etc. On the virtualized side, it goes even farther, where at the lowest capacity or most cost-effective end, you have a C-Micro solution, which C-Micro is one of our partners. I'll talk about C-Micro. The concept there, again, is if you need a limited amount of performance, very cost-effective, operates very well, all the way up to shared infrastructure solutions on the high end. So my point to you is simply this. As you look at your workloads, and as you look at the types of workloads that you're running, maybe it makes sense to right-size specifically for those types of environments and share the infrastructure across the entire chassis. So this is a set of suggestions on the workloads that you may be running. Starting on the left-hand side at the top with the C-Micro solution, the 2 microservers, Microservers, the 2P servers, and then the 4P server. Everything from web apps that can run on anything to if you're running LampStack or File and Print. Microserver solution. They don't require a lot of horsepower. If your customer wants a dedicated server, fine. Plug one of these in. You get 12 and 3U. All the way up to as they grow again, as they have more demanding apps or start getting potentially into virtualization, you get to the 2P servers. And then finally, if you have really high-intensity virtualized environments, you get up to the 4P servers and beyond that. So these are just some ideas of the categories of workloads we've seen work in different types of servers. And again, the concept is pretty simple. Pick only the amount of resource you need. It saves you money, and it can either drop straight to your bottom line, or it means you have a competitive advantage in what you offer your customers. So, now let's talk about complex versus simple. So we'll start off with a real-world example, right? So we've got our Chevy Tahoe on the left-hand side. You'll notice I chose a pretty pimpin' Chevy Tahoe. I'm not sure where that picture came from. Versus a Humvee. And the question is, gee, what's the best solution for what you're trying to do? And the answer is, it depends what you're trying to do. Just like a Chevy Tahoe is great for all kinds of different things. It's got lots of features. You can kind of get it anywhere. But maybe you're getting stuff you don't actually need. If you're trying to drive around in a really rough country or deliver hardware, etc., then maybe you need a specialized type of environment. Maybe you need a specialized set of equipment to handle that need for you. And as you expect, the same concept is true for regular servers and hyperscale optimized servers. We have servers like this, so do other vendors out there. And it's pretty simple. General purpose server on the left-hand side. Lots of management abilities. It's got lots of features inside. It's a very capable server for all kinds of different environments. Maybe that's what you need, and it's perfectly valid to build on that. Maybe you don't need all that stuff, and maybe you don't need all the features, and you don't need the sophisticated management. Maybe you just need IPMI and ECMI. Maybe if you optimize for power consumption, then again, that makes your OpEx that much lower. So the concept of hyperscale specific hardware is pretty simple. Aim at a point and deliver only what's required to hit that point. And microservices is a great example of that. So, we talked about this a bit, and Moore's Law has been following us for a long time, and sure enough, server capability has been increasing really fast, and it means you can run really high-performance clusters. If you're doing online transaction processing, if you've got a virtualized environment, then sure enough, the fact that you're adding horsepower is really helpful to you. Less servers to manage, more stuff you can put on the server. But again, if it's a dedicated environment, you probably don't need that much performance, and that's where the microserver was born. You're below the curve, and your customers don't need that much performance, so deliver only that performance. Here are the different platforms. Again, I'll talk more about C-Micros, that will be a new technology to you guys in just a minute. I'll talk more about the microservers. Here's C-Micro. C-Micro concept is kind of an interesting concept, right? Because in 10U, you basically get a rack in a box. C-Micro took compute modules that were about this big, using Atom processors and using their own technology, their own ASICs, etc. They allow you to virtualize I/O and virtualize capacity within the box itself. So you can carve this thing out to a certain extent any way you want. Gives you 64 processor cards, 64 compute cards. Gives you the capability, depending on the application, of 40. That's 40, 2-socket servers, and it gives you storage capacity for storage cards, capacity for network cards, etc. This again is your rack in a box. And if you've got customers that don't need a lot of performance and you want to be able to carve up your resources for them flexibly, this is a very interesting way to go. So this is kind of the epitome, if you will, of right-sizing specifically to a fairly low-capacity environment. This gives you the opportunity to be really flexible in what you deliver to customers. The microserver is the step up from that. So what you're seeing there is a 3U box. It's got 12 one-piece servers in that 3U box. Again, cooling and power is amortized across the entire chassis. And it lets you do things like deliver 4 times the density that you would get from traditional servers. Say something like 75% in cooling costs and operational costs, right? So again, taking a look at how you derive money out of your environment, when you right size, you kind of get to do things like this. So this is energy use simply, again, if you own your own infrastructure, what does it cost to run the server? The 2P, the microserver, it costs about $121 a year, depending on where you are and how much you pay per kilowatt hour. For a typical server, $191. So that's a difference in over 3 years of $210 per server. And you guys don't run one server, so if you look at 144 servers, that's 30 grand in savings that you can do whatever you want with over 3 years. And as you add additional servers, the savings go up. Okay, so maybe you're thinking, well, gee, Steve, this isn't really apples to apples, right? Because maybe I'm not looking for power savings. Maybe I'm looking for additional revenue that can be driven out of my rack. So if you look at it this way, this is an actual customer, and it's a managed hosting environment, right? So higher revenue. But this is an actual customer who stopped using 1U servers, and they switched to the microservers, in this case the 5125, which is based on AMD 4100 series. They were able to put 122 more servers in a rack. This is earning them $1.6 million additional per year in revenue per rack, simply from the increased density within their environment and what they can generate per node. So again, this is how effective right-sizing would be, and this is what you can do in your environment. This is another customer example. This is online.net, and this is actually who we worked the original microserver concept with. Online.net is a French hosting company. They deliver dedicated servers for each of their customers, and they came to us and said, can you help us deliver a server that's the lowest possible cost, lowest possible operational cost? Yes, we can. We originally delivered the microserver in 2U form factor It allowed them to deploy over 250 servers per rack, and they were able to take the operational savings and reduce their price to the point that they had a significant price advantage over their competitors. So they're at the lowest level, their monthly rate for the lowest end servers actually dropped by something like 33%. That's the kind of savings they passed on to their customers and grew their environment. Let's take a look at a virtualized environment. So if you're virtualizing, maybe you're like Island. Island, same concept. They actually use a virtual environment or hybrid environments where they have physical servers and virtual servers. They wanted to be able to virtualize servers, so in other words, have something with sufficient horsepower but still take advantage of shared infrastructure. So you can grow beyond simply a microserver. We and other folks have multiple node servers, so within a 2U chassis you end up with 4 2P servers. And Island took that same concept and basically delivered the same capability they've been delivering with typical servers for a lot less money and a lot less operating cost, again giving them a competitive advantage. So again, different architectures that are available. This is what it looks like. It's pretty simple, right? But as you look at the simple concept of combining multiple servers within a chassis, you also have to make sure it's something that you can work with. So this is, again, in 2U, 4 independent 2P servers, each with all the capacity you'd expect in terms of hard drives, memory count, etc. But you don't really want to have to swap out the entire box if a server node goes down. So one of the tricks here was making each node serviceable while it's up and running. So what we wanted to do is make sure that we're not reducing your ability to service your customers while at the same time delivering a more efficient environment. So this is what a 2P version looks like. This is what the 4P version looks like. And obviously, you've got to have a pretty hot and heavy virtualized environment with some really high-end application running on this. But the concept here, again, multi-node servers to a higher degree. So this is 2 4-socket servers in 2U, still with a lot of drives, still with capacity for lots of I/O, et cetera, and still sharing the infrastructure across the entire chassis. So those are the servers. And then finally, ideally, as we look at the business coming up, and as you guys grow your business, at some point you're going to have trouble keeping up with demand because you'll land a big customer, all of a sudden you'll need a lot more servers deployed. One way or another, you'll see volatility of demand. That's what we see for customers as they grow beyond a certain size. All of a sudden, they need 100 servers one day, or they need no servers for a couple of months, whatever. So, how do you deal with volatility of demand? First of all, again, looking at the rack, think in terms of integrating at the rack level, right? So we and other people do this. The idea is you buy multiple servers, already integrated into the rack environment, everything already cabled together, already tested, etc. So you wheel it into your data center and you switch it on. Plug everything in, everything's been tested, it's ready to go, and you've deployed a bunch of servers in a couple of hours instead of the amount of time it typically takes to rack and stack everything. Obviously, you can get beyond that into actually deploying at the modular data center level, but again, a certain amount of size is required for that, so that may not be applicable to a lot of the folks in the room. I wish you all well, by the way, but at some point it becomes a problem at that level for you. But also, how do you manage those things? So I'm sure you guys are all familiar with Openstack. The concept behind Openstack is to deliver technology that's standards-based for hosting and for cloud environments. We really liked that idea. We really liked the idea of innovating within standards. So as soon as Openstack was created, we were the first hardware provider there. The concept to you, though, is we've just delivered the first solution that's top to bottom using Openstack. And this is a reference architecture for building a cloud environment that'll scale, first of all, from 6 to 60 nodes, so it scales very quickly. It's license-free because it's all open source stuff. And it gives you everything you could possibly need to deploy the architecture very quickly. So you don't have to have all the expertise required to deploy a cloud-type environment. A lot of hosters we talk to are building a cloud environment and are looking for solutions like this. So it's built on something we call a crowbar for management. We wanted to deliver a solution for managing and deploying servers based on open standards, and we developed this thing called Crowbar. Crowbar cuts deployment of your cloud environment down to hours instead of days. And in fact, the customers that have tested it, they've seen that not only did they deploy in a couple of hours instead of a couple of days, but it also saved them a huge amount of development time. And you can build your own capability on top of it. On top of Openstack, you see down at the bottom in the URL there, you can actually get the bits and develop your own capability on top of Crowbar. We call those bar clamps that add additional capability on top of Crowbar. And if you need to build different capability, you need different types of capability, that lets you deploy it and deliver it very quickly. So the very first complete OpenStack reference design, and these guys were also here, were really successful using it. This is DreamHost. DreamHost was looking for a way to deploy and manage their cloud environment very quickly. They really liked this because it delivered exactly the capability they were looking for. So again, the concept of making sure you are aiming at the problem and solving only for that problem, not adding stuff on top. They really liked what they saw with Crowbar, and they feel it saved them 4 to 6 months of their own development work in terms of delivering the capability. They are deploying using OpenStack Cloud, and they are seeing a lot of success. They're very happy about that. All the case studies and all the customer references I'm showing you here are available on our website, and a lot of the guys are actually here to talk to. Again, please don't take my word for this stuff being effective. The reason I'm dropping names here is to help you guys, give you references to talk to and understand what these guys have seen from using different architectures, different technologies. So, pretty simple concept. Hopefully what you've seen is some different ideas of ways to deploy services, right? You can get there from here. You can continue working in the same architecture, same technologies you're used to using. You can absolutely grow that way. My point to you is simply this. There are new architectures out there. There are new ways of doing things, especially as you get into cloud-type environments, new ways to get to the end result. Consider those. Look at your data center environment, look at your rack environment, look down to the node level, and think about how you manage it. And as you reduce operating cost, then basically you can pass it on to customers, or you can deliver more margins yourselves, and either way, that's a win. So, thank you guys very much. Please let me know what questions you have. I have some minor prizes for folks that ask questions. Please let me know what questions you have.
You're qualifying a lot of your statements with low power or low performance.
No, I hope I didn't say low performance, low power, yes.
Or low power.
Yeah.
Were you also meeting low performance, or
So as you go down to microservers, they sure enough deliver less performance than a 4P server. So absolutely yes, but I didn't mean to imply that they are lower performance than the microserver versus a 1P, 1U server. It's not low performance.
Well then, my follow-up question then is, are these systems that can be combined together, or are they treated as separate servers? Are they modular in the sense that, if I put in one of these microservers and another, I can combine them all so that you see a multiprocessor server?
You can virtualize across them that way. They do not intrinsically connect, so two TPs look like a 4P. Okay. That was your question, but yes, you can absolutely do all the things you're used to doing on a 2P server and grow your environment that way. We do see a lot of people, the majority of virtualization is on 2 sockets, so we do expect all that.
Is that easily changed, or what if I want to expand that, add more processors to that virtualized server? Do your tools support that?
So let me make sure I understand the question completely. So you've got microservers, 1-socket servers, and you can plug in multiple servers and virtualize across them. You can take 2P servers, virtualize across them, right? So you can always add to your virtualized environment that way. And as you plug in new servers, then they can come into your environment. So is that your question? Or we don't plan to deliver any technology that allows them to hook up and act like an SMP server or a NUMA server or something like that, simply because most people don't want that, right? 2P, 4P servers exist now. Was that your question?
Yeah.
Okay, all right. So I don't want to get sued if I hit you in the head, so I apologize, but nice catch. All right. Great question. Other questions? Yes, sir. I can't throw that far, by the way. I'm just wondering.
Yeah, that's right. So what's the best way to engage Dell to talk about some of these things?
We have a booth, we're at booth number 651. Is that right, Jeff?
Yep.
651. So we'll have folks there talking about Crowbar and the Openstack solution. We'll have the servers there too, so you'll actually see the microservers, et cetera. And that's how you start the conversation. They give you the information, and then you kind of move on to the next. So yeah, please come by the booth. By the way, there's also going to be a really cool on live gaming demo where you can play the on live game, which looks pretty cool, and I won't be here to enjoy it. So, great question. Okay, well, thank you guys very much.